So just make a little brief intro to get you into this concept. Let me say, the real concept starts from Futurchem technology. Is sometimes as LC3 concept, but is a limestone calcine clay technology. Actually, we have a patent, and as yesterday was mentioned by Michael, it's one of our legs to get to the point of reducing the CO2 emission. From this concept that is, fully enforced in Denmark, but also in Belgium and in Benelux area, also in northern France. So there are cement based on calcine clay on the on the market. We started to make an evolution, for the other part of the way of make sustainable industry. So from the concept of cement, low carbon cement, we move through low carbon solution. And we have on the market, because this morning Frank also explained you there are some on the market and someone else on the tube, but the three on the market are InWhite, that is a binder, which is allow you to get to high performance, and the key properties, the key value added is to make it possible UHPC with your, let me say, material. So flexibility with the local product. Then, obviously, we move to something that is more ready to be used. There are extreme Excel, so you need just to add water. In this case, all the technology, all the, let me say, the expertise behind making the design to UHPC is already gone, let me say, is guaranteed by the product. The two products have two different, let me say, application target, but mainly one is more for infrastructure, the other one is more for aesthetics, and also the size of the maximum aggregates is a little bit different. But this is mainly the concept that I would like to follow you. This is the innovative solution part, so moving on reducing the carbon footprint by reducing the material used in the construction. So lower CO2 emission per square meters. Why choose our solution instead of the other? Let me say, UHPC is now it's a technology, advanced technology for ultra-high performance concrete, and we know there are many benefits on this, like mainly based on fast building part, because you, based on precast, based on this material, you can have a very fast building, reducing the rate of, let me say, wasting time during the construction. For sure, the use of having less heavier material is a benefit for the cost of transportation. And then, generally speaking, having a thinner material is a benefit for the overall construction because you have more square meter available for the people inside. But what is more with the InWhite is the Futurchem technology. So compared to the normal UHPC, having inside the concept and the technology of Futurchem, you can, let me say, is a combination of the two solutions. So less material and then material that inside has lower carbon footprint. So it's a double effect approach on the construction, because Futurchem, compared to the other, let me say, cement, is rely on more sustainable material. So it's not relying on silica fume and the other, but on calcine clay. This is more natural. And limestone, it's the second material all over the world available. And then the key elements that we would like to share with you is the low carbon technology. So, you can achieve the same performance while lowering the CO2 emission. This is very the key point. And then using material like calcine clay together with limestone, you have an enhancement of the durability. So all our products that will be also shown by my colleagues are also let me say, tested with different exposure classes and so on, then guarantee you the durability. So, because sometimes the durability, low carbon, let me say, attributes are not aligned together. So this is, let me say, an intro on this concept, and now my colleagues Tom and Anthony will guide you through the material, so the performance, and also how to use it. This is very important because Anthony with the InBind, so it's more technical, so we need some knowledge behind, while for Extreme Excel is more to understand which is the application, just to find the right compromise on the water. Okay, so please, Tom.
Thank you, Stefano, for the introduction. My name is Tom Rijkenboer. I work for Aalborg, Portland, Belgium, as a technical sales manager. And one of my tasks is also to develop the innovation stream, the new products we have developed for ultra-high performance concrete. And I will give some more technical details on the two premix products we have in our product range, Aalborg Extreme and Aalborg Excel. The starting point, let's say, it's about the philosophy of traditional ultra-high performance concrete, where we have some characteristics that are specified to make this high performance concrete. So the water binder ratio for reaching high level of performance is very low. We have products with water binder ratio of about 0.17, 0.18. And most of the traditional UHPCs, you have silica fume, which is a very fine powder that with a content of about 17 to 20% by the weight of cement. And also the ultra-high performance concrete is characterized by a high packing density. So the granulometric curve and the fine fractions is very important. We use also a low sand fraction, which goes up to maximum 3 millimeters. And that is also the reason is to have the good packing density. So it's more in a category of mortar that we are working than real concrete. So another condition is to have a product that is self-compactable, self-leveling, and therefore we add some superplasticizers already present in the product. Then if we take a closer look in the composition of these premixes, we have, of course, first the binder. And this kind of mixed design, you need a real high content of binder, and that can represent up to more than 50% in weight of the product. Of course, then you have the aggregates, or let's say the sand fractions that we use. That is a maximum diameter between 0.5 and 3 millimeters. And then in our approach, we, of course, to make the UHPC, you need also the fibers to have the flexural strength. And in our approach, that's maybe a bit different than other similar products. We leave the choice to the customer which type of fibers you can add, and also the dosage. So the fibers and structural applications we apply is the steel fibers, or you can also choose for stainless steel fibers. And for the decorative applications, you have more the PP fibers, polypropylene, or PVA, or even glass fibers. If we now take a closer look to the binder itself, In the traditional UHPC, the binder is composed, of course, of cement, the Portland 71525R, to have the high performance. And then you have the silica fume, which is a byproduct of silicon and ferrosilicon production. But these particles are ultra-fines, we call it. It's up to 150 nanometers, so it's in finer range even than cement. And as filler, yes, there are different possibilities. You can use fly ash, calcined clay, or even limestone filler. And then the fourth component is superplasticizer, which we introduce in a powder form into the premix. But these are last generation polycarboxylate superplasticizers with a high performance. So this is how it looks for a traditional UHPC, but what we have now developed with Aalborg Portland is based on the future sim technology, which was already explained. So, in fact, what we do in the binder is we have still, of course, the cement, but we don't use silica fume, and we use instead of that the future sim technology with adding metakaolin and limestone filler. The reason why we don't use silica fume is because the availability is sometimes a problem. You know, we are working with a white cement, and also white silica fume is very rare to find. And also the price volatility is sometimes a risk. So that's the reason why on the future sim technology we add the metakaolin and the limestone. So these are the two products, Aalborg Extreme and Aalborg XL, that are the premix products. It's very easy to use. These products have only an addition of water, and of course, as these mixes are very fine defined, you have to add the water, and it is very important to follow the right dosage of the water, and to obtain then a self-compacting consistency in the final product. So the first product we launched is the Aalborg Extreme, and this is a product that is mostly foreseen for structural and semi-structural applications. So that is, for example, bridges, balconies, stairs. And this is for the structural application, mostly in combination with steel fibers. The water dosage is 7.8, 8.2%. Let's say on one bag of 25 kilo, that means you have to add around 2 liters of water. It's also a shrinkage reducing mortar, and here we have a maximum particle size of 3 millimeter. After the Extreme, we developed a second product, the Aalborg XL, with some slight differences. It's mostly about the maximum particle size, where we have a maximum 1 millimeter instead of 3 millimeters. And that allows to have even a better flow, and also for more complex formwork. This product has a better performance. And in this product, we oriented more into the decorative products, final products, such as cladding panels, sunscreen lamels, also ornamental elements or urban furniture. to give you an idea of the mixing instructions, so it is a special premix where the superplasticizer is included. And so after adding water, in the beginning you can also add pigments if you want, but it takes a lot of time and a lot of energy to make to reach the good consistency. And after 2-3 minutes, it's a bit strange. It's a dry, very dry mix with forming little nodules. And after some more time, you have the small nodules becoming bigger, and then you come into the phase where we call it the clay phase. And then going up to 5-10 minutes, we arrive at the final consistency, and this is a very flowable mix with a spread of with a cone about 90 centimeters with the big cone, but we do also some tests with American standards, and this is with a smaller quantity of mortar where we have the spread of around 29 centimeters. To mix this kind of products, you need a mixer that is really powerful, because the reaction of the superplasticizers can take some time, and so the most suitable mixers are the pen mixers, and you have also to consider that the capacity of the mixer is, in traditional concrete, maybe 500 liters. Then you have to consider that it's almost the half of the quantity that can be mixed in this kind of mixers. So in with the fresh properties, as said, the flow is very important. You have with the small cone method spread of 29 centimeters up to 30, so there's not a lot of difference between the two products. About density, the Aalborg Extreme is a little higher because of the maximum particle size, and then also the shrinkage we measured is lower values than traditional UHPC. In traditional UHPC, you are often at the level of 1,000 microns per meter, and here we have results of around 600 for the Extreme and 700 for the XL. And then, of course, the main difference is the maximum particle size. 3 millimeters for Aalborg Extreme, 1 millimeter for Aalborg XL. Then the mechanical properties. Of course, the mechanical, the strength, the compressive strength. We have, at one day, we reached already a level of more than 75 MPa. We even had results of around 100 MPa. So these mixes are very reactive, and there is a high cement content in it. So that makes that you have the strength development mostly in the beginning of the hydration. After 28 days, a slight difference between Aalborg Extreme 120 MPa characteristic and 130 for the Aalborg XL. And then the flexural strength is, of course, depending a lot of the fibers you use. But even without fibers, we have already a flexural strength of 14 MPa. And the E modulus is around 50 gigapascal. So with these mixes, of course, we try to have a very dense material, and for the durability, of course, it's also a material that is very less that has a low porosity. So also for chloride migration, the values are very low. And we did also the tests for the freeze-thaw cycles, and we see that there is almost no risk for freeze-thaw. These values are very low, almost zero. And also the water absorption is very low. So in a nutshell, we see that the ultra-high performance concrete technology, or the high performance concrete technology, is a growing technology. We see each year that the products are popping up in more projects. And of course, the ductility that is a main benefit of this kind of material. So the main objective to use this kind of mixes is, of course, to reduce weight. We can state that in most of applications you can reduce weight by 40 to 60%. So, and the transportation costs, that is also a benefit. And the advantage also of this premix product is it is very easy to use, and it saves, let's say, also the development and the R&D costs for the customer. You have a product with very stable characteristics, and that makes that a customer don't have to invest so much. You can rely on the specifications of the product that we can share with the customers. So also the color-wise, we choose for the white cement, of course, because also the characteristics of our Portland CEM1 525R are very suited to have this high performance. And then yes, having a product that is self-compacting, that makes it possible to have a long open time, and so you can also use it in more industrialized precast production process, because it's a very stable product. Okay, I will now give the word to my colleague Anthony, who will talk about the new concept of InBind.
Thank you, Tom. My name is Anthony Binet. I'm technical sales manager for France. The InBind is a new development for InWhite. InBind is the binder used in all InWhite products, Extreme, Excel, and future development. It's based on future same patent, limestone calcium clay technology, by using the highest raw materials to ensure the highest pozzolanic reaction and whiteness. InBind has been tested by a selected customer with good result in terms of fresh and mechanical properties and durability indicator. The idea of commercializing InBind separately is to allow a customer for total customization by using their own aggregates, fibers, and additive. With the technical support and the customer practical expertise, we will be able to develop the mix, their own production process to achieve the mechanical properties and durability indicator that they need. If we must condense in one slide the main benefits of InBind, this is one. When you use InBind with the good aggregate and the water binder ratio 0.21 and 0.27, ultra high performance is guaranteed. It's a flexible solution and total customization. It's possible with InBind because you can use your local sand, your local admixture, and the fiber with your local source and your local partners. The performance of InBind is very reliable because will not change batch to batch due to your continued quality control with the RQT. And also, it's very important. Cementir will provide technical support to assist the customer during the initial recipes design. We have a lot of results for the durability and mechanical properties with InBind. I want to highlight the main benefits and features for the InBind: high early and final strength. The whiteness allow with InBind you can add a pigment and target a specific color with the InBind. It's very flexible because InBind use just one silo. It's very different with the competitor solution. When you develop a solution of UHPC, you use 3 silos against 1 silo with InBind. You use the binder for your application. And the InBind, it's you answer for the 10 key points for the standards of UHPC. InBind can be used for the white cast application, where the compressive strength and the durability are required. For UHPC sunscreen, facade, and structural fence, and the outdoor furniture and more application. In terms of mechanical properties, we were able to achieve the main compressive strength with 130 MPa by cylinder, and the flexural strength it's 20 MPa. The mix has with a water binder 0.21 and 3 sand ratio and 200 kilos of steel fiber. I hope you are ready to test the performance of InBind in the future. It's a very customizable for application. It's for the precaster, a solution with 1 silo. Very practical.
Merci. So we can go over some of our reference projects that we already realized until now. So we have as well in the commercial and residential building some references, and also in infrastructure project, and also leisure and city landscape and furniture. So in commercial and residential building, we are talking about as well facade cladding flat panels. Then you have what we call resile panels with and formwork, and then also for the balconies, we have possibilities to make bigger cantilevers than with the traditional concrete, so you can save a lot of weight. And in this case, we also made these balcony frames with the customer, but this project will be explained a little later by Enjoy Concrete. And then also the lamels for sunscreens in vertical position and horizontal position. That is also more and more in the projects. This is a project in the United States where they made these cladding elements. And these dimensions, that is, of course, what is the most interesting. It's up to 3 meters by 1.4 meter. And we have a thickness of 19 millimeter only. And in this case, the elements are sand blasted, and they added also a small aggregate to the mix, because normally the premix is defined and is fixed, but we already did some tests also for Aalborg Extreme, for example, to add a little aggregate, and we go up to maximum 25%, and then you can also achieve this result sandblasted. You can also polish it and make a terrazzo. But the most surprising is, of course, the small thicknesses that we can achieve with this product. This project is in France, Reims, for the famous architect Rudy Ricciotti, the architect that has a lot of applications with UHPC. And here the elements that were made were about 2 meters 60 long. In total, we made 6 kilometers of these lamels with Betsinor. Betsinor was the precaster. And the dimensions, it's only, this is not correct, sorry, it's only 35 millimeters thick, and a section of 20 large. And we have also rounded elements in the facade and in 2 directions. So and the formwork, even if it's complex elements, you have a lot of more possibilities than traditional concrete. Mesh panels, this is a project also in France, the south of France, Antibes, also made by Betsinor. But in this kind of mesh configuration, yes, you have the liberty for the formwork. Let's say you can work with formwork in silicon or in latex even. So this makes you can be very creative with these kinds of forms. And infrastructure, we made some bridge projects in the Netherlands, also in France, a bridge in Amiens, and a project in Antwerp with very thin architecture and thin stair elements. So this was made with our customer Waco, and the engineering that is also a part that is important to make this kind of products. We had a partner FDN Group because it is not easy in a concept phase of the project to define the thicknesses, the fiber type, the fiber dosage. But We also have to say that the knowledge for that, we don't, the know-how, we don't have it in-house, but we have found some external partners that can help us with the calculations of these structural elements. But it is still to be developed. It's not so easy to find the good partners for engineering. A bridge deck, 8 centimeter thick, yes, 85 millimeters, and dimensions 9.3 meters by 3 meters. And yeah, this is for pedestrian application and also for bicycle bridges. It is not yet done, and yes, for vehicles or for trucks, but it's mostly applied in pedestrian bridges or bicycle bridges. And the leisure and furniture elements, you can also have, yes, a challenge to make very thin elements. It's very nice designs with small, slim dimensions. This is a project in China. There's a project in Spain, some tables, benches, so you can even make lamps or things like that in for the furniture market, and it is very durable. And this is a project in Qatar for a British architect, and this was made recently for the football championship in Qatar. It's a playground for kids. So yes, all these elements are very slim, and yes, nice result. Okay, this projects show that yes, you have a lot of new applications where this product can be used, and of course, for the durability, it's good to reduce the weight of the concrete, and also with the FutureStem technology inside, we have let's say 2 advantages where the product can rely on.